In this segment, we'll finish up our look at the object base class. We'll also discuss upcasting and downcasting. So looking back at our implementation of vector here, how do we revise vector.equals to properly redefine object.equals? Obviously, we'll need to change other to a type object. So let's do that. And I guess we'll need to do it in margin vector as well to be complete about it. Now, by the way, don't worry about the compile errors that are appearing in the bodies of the methods. We'll get back to those in a minute. But first, I need to ask another question. Won't this change break the calls to vector equals in vector test? We are, after all, passing vectors, or to be exact, really, margin vectors here, because we did create a margin vector and pass it. Up here, it's a true vector we're passing. But in either event, they're not objects, right? So won't it mismatch? Returning from a pause, well, the answer is fairly straightforward by now, I would hope. No, it won't break them. An object reference can point to any object type, as we emphasized in the last lecture. So you can just pass vectors to object parameters, or margin vectors to them, and it'll be fine. But now the compiler is griping that we can't refer to other.x and other.y for that matter. I guess that makes sense since object has no x member, but we are really passing margin vectors, or vectors. They really do have x members. That's what we passed over here in vector test, after all. So can't we get to them? No, we can't. At least not via an object reference. And here's a critical point about ISA relationships. The compiler judges what methods and members are available in an object by the type of the reference pointing to it. So if you point an object reference at a derived object, like a vector, the compiler won't allow access to any other methods or members than those declared in object. Okay, but wait a minute here. We went through a whole song and dance in the last segment or two about how polymorphism meant that even if you had a vector reference, the margin vector version of polymorphic methods, like equals, would get called. Smart objects, embedded tables of functions, the whole 9 yards. So now we're saying that unless we point to a vector object with a vector reference, the compiler will deny the existence of any vector properties? Isn't that a contradiction? Think carefully here. Let's see if you can come up with an answer to that. Returning from a pause. No, it's not a contradiction. Polymorphism works when the reference type knows that the method in question exists. Then if the object is actually a subclass type, its subclass version of the method gets called. For instance, a vector reference knows about the equals method and about all the other vector methods. And if it's pointing to a subclass that overrides one or more of these, you can call them through the vector reference and get the overridden version. But you can't call a method declared only in the subclass unless you're pointing to it with a subclass reference. Okay, so what do we do to tell our equals method, hey, I know it's an object reference, but that was just to match the general object.equals. We're really passing a vector or a margin vector, and it has x and y members. Trust me on that. To do this, you downcast the reference, like this. Give it a slightly humorous name. This says cast the object reference, other, into a vector reference, which will be able to see the x and y members. And you can then use really a vector x and really a vector y without compiler complaints. And you can see the compiler message has gone away here. But you'd better be right. To see what I mean, let's try a little call of vector.equals with a string. We'll throw a couple lines here into vector test to do that. And I'm going to be calling v1.equals on string not a vector. Now this won't compile, right? That's question 3. We've got to have a vector there, right? Thinking about that a bit. Turning from a pause, yes, it will compile. There's no error message here. And that's because that's an object parameter, and it points to anything, including strings. So the object parameter here doesn't care what you pass. Everything's an object, including strings. So then when does this go wrong? That string object doesn't have any x and y members. It's got to go wrong somewhere. Turns out that it goes wrong when you run it, and not till then. So let's try it out. Got vector test here. I'm going to go and do the run of the application. And we get our first, though I assure you not our last, class cast exception. This is the Java VM's way of saying, you promised me that would be a vector, or something derived from it, and you lied. There's no vector here. This is a string. Downcasting is a necessary, but inherently dangerous operation. If you downcast incorrectly, you only find out at runtime. By contrast, upcasting, or assigning a derived object to a base reference type, is always safe by virtue of the is a rule. But going the other way, downcasting is okay only if the target object really is of the correct type, and it's up to you to make sure that that's so, or you'll pick up a class cast exception error when the code runs. So in summary, to redefine equals properly, you override the object version with an object parameter, but you downcast the parameter to the expected type, and you only pass the expected type or a subclass of it when you call the equals. Now there is one final important point about equals. What if you don't redefine it and instead rely on the default object implementation? Object does supply one, and it works for any subclass, but it doesn't do what you might expect. The object.equals implementation does a shallow comparison. In other words, it returns true only if the context object and the past object are the very same object. This is a complete contradiction of the deep comparison purpose of equals, but it's easy to implement. I'll ask you to do so in a moment, in fact, and it works in a sense for all subclasses, since comparing references requires no information on the subclass's content. But it is a bit of a trap, because forgetting to redefine equals, but using equals anyway, will compile, but do shallow comparisons. Question 4, then, to reinforce this concept, I'd like you to please write the body for object equals, given what we just learned. Now, don't be intimidated by this. It's actually not a very long function at all. It can be done with a single return statement, returning the value of a simple comparison. So there's the code, and I want you to put one short line right here. Turning from a pause, well, all you really need to do is return this equal other. This reference, the this reference, points to your context object, and other points to the other object, and comparing them with equal does a shallow comparison. And that's all there is to it. Now, the other object methods are important, but they're beyond the scope of this discussion. Let's just very briefly review them. First of all, several object methods have to do with locking multi-threaded code. Every object is able to participate in thread synchronization in Java via the notify, notify all, and the wait, and then down here the wait, well, there are various forms of wait methods. If you take a course on multi-threaded programming using Java, you'll learn a lot about these methods. And there's finalize. Some languages, like say C++, offer something called a destructor. And these are methods that are called to clean up an object before it's deleted from memory. The Java finalize method is similar. The garbage collector will call finalize on any object just before it's deleted. Now, the object version of finalize does nothing. But if you have some cleanup to do with when an object is deleted, you can redefine finalize and the garbage collector will call it. However, critically, you can't be sure finalize will be called promptly. The Java garbage collector is inherently lazy, and it gets around to collecting unused objects only when it must, sometimes minutes or literally even hours after you've released all references to the object. So if you're counting on finalize to, say, close a file that your object has open, it may take a good long while for that to happen. As a result, most Java programmers ignore finalize and instead define and directly call their own cleanup methods. getClass. getClass is part of the reflection system in Java. Every class you declare has a reflection object available to the program at runtime, and this object gives complete details about the class itself and allows powerful programming approaches, powerful at least in a strictly typed language. A dynamically typed language like JS would take them for granted. You can get more into reflection on a class that goes deeper into Java particulars. And then finally, there is hash code. This is added to object so that any object may be used as the key to the library hash table classes, like hashmap. It returns a hash code, a pseudo-random integer that's based on the content of the object. We'll see that this is convenient in a later topic on the Java collection classes.